Ah, well-deserved vacay. Finally. This time, you're off to see something new. It's an ocean on one of the Uranus's moons. Alright, just kidding. This destination is not a vacation spot yet. But yeah, there are definitely some impressive oceans out there. Hey, don't say you thought oceans can only be found on Earth. But before diving into Uranus moon's oceans, let's talk about Uranus itself first. The seventh planet from the Sun, and the coolest cat in the solar system. It's got 27 moons, and 4 of them might technically have oceans. That's more than most people have friends. All these moons are like Uranus's mini-me's. They tilt at the same crazy angle as their parent planet, 98 degrees to be exact. And Uranus is so unique that it orbits the Sun on its side. That means its equator is almost at a right angle to its orbit. Talk about rebellious. But why is Uranus like this? Well, some astronomers reckon it's because it got knocked on its side by a massive collision with another planet, and that impact might have actually created Uranus's moons. Fun fact, those moons have pretty particular names. Instead of mythical figures, most of them are named after Shakespearean characters. I mean, who needs Zeus when you've got Juliet and Desdemona? Discovering these moons isn't easy. They're super dark and located billions of miles away from the Sun. It's like trying to find a needle in a haystack, except the needle is smaller than your pinky finger. These 27 satellites are divided into 3 groups, 13 inner moons, 5 major moons, and 9 irregular moons. The irregular ones are rebels with retrograde orbits, while the others are prograde and go with the flow of Uranus. The big boys are Miranda, Ariel, Umbriel, Titania, and Oberon. And they're all in Uranus's equatorial plane and are big enough to be round. They've got craters and canyons and cliffs. Oh my, these moons also formed from a giant impact that tilted Uranus on its axis. That's why they're all tilted too, and because of that tilt, they have crazy seasonal cycles, just like Uranus itself. But we haven't found all of Uranus's moons yet. The little irregular ones are sneaky and hard to detect, so who knows how many more there could be. But let's talk about the really cool stuff, what these moons are made of. We're not entirely sure, but we think they're made of rock and ice. Miranda is the most icy one, while the inner moons are probably just dusty. And the ones beyond Oberon's orbit? They're likely captured asteroids that could be rocky or icy or who knows what. But here's what really sets Uranus's moons apart. They're all tilted together with Uranus. That's wild. Exploring these moons could teach us so much about how ocean worlds form and stay active. Titania is the biggest moon of Uranus, but it's still less than half the size of Earth's moon, with a diameter of about 1,000 miles. It's also the 8th heaviest moon in the whole solar system. They named it after the fairy queen in A Midsummer Night's Dream. Titania's color is gray, and it has some shiny patches that scientists think are frost. It's made up of a mix of ice and rock, just like all the other moons close to Uranus. Oberon is the next biggest moon of Uranus, named after the fairy king in Shakespeare's play. It's almost the same size as Titania, and also has a half ice, half rock composition. But Oberon's surface is way more cratered than the other Uranian moons. Umbriel and Ariel are the 3rd and 4th largest moons of Uranus, with diameters of 726 miles and 718 miles respectively. Umbriel is named after a bad spirit in an old poem, and it's the darkest of all Uranus's big moons. It only reflects 16% of the light that hits it. Scientists don't know why it's so dark, but they think a bright ring around a crater might be caused by frost deposits. Ariel is the brightest of all Uranus's big moons, and it reflects over a third of the light that hits it. It's named after characters in both Pope's poem and Shakespeare's play. Ariel looks like the youngest moon because it only has a few small craters from recent collisions. Miranda is the smallest of all these big moons, with a diameter of about 292 miles. NASA says it looks like it's made up of parts from different bodies, like a Frankenstein's monster. Miranda has 3 big features called coronae that are unique to it. They're lightly cratered with ridges and valleys, and they're separated from older and more heavily cratered parts of Miranda by sharp boundaries. It also has giant canyons that are up to 12 times deeper than the Grand Canyon. Scientists don't know why Miranda has such different features, but one theory is that it got smashed apart by a huge collision and then put back together all wonky. All these big Uranian moons are stuck facing Uranus all the time, just like Earth's moon. Uranus has got some seriously dope features, but the ring system is where it's at. And get this, The ice giant's moons actually have a hand in shaping those rings. Uranus has 13 inner moons and 13 faint rings, and they're all connected like one big cosmic family. Cordelia and Ophelia are like the guardians of the outermost ring, Epsilon. These two shepherd moons keep all the particles together, with Cordelia being the closest to Uranus's surface. But here's the kicker. There are at least 8 other tiny satellites hanging around in that area, making things super crowded. NASA is still scratching their heads trying to figure out how they don't all crash into each other. The inner moons are half ice and half rock, but we don't know much about the outer ones. NASA thinks they might just be asteroids that got caught up in Uranus's gravitational pull. Either way, Uranus and its moon squad are definitely out of this world. Apparently, Uranus's moons might have salty oceans hiding under their frozen surfaces. And the farthest ones from Uranus, Titania, and Oberon could have oceans that are 30 miles deep. That's deeper than the Mariana Trench, 7 miles. But even Ariel and Umbriel might have oceans around 19 miles deep. NASA used some fancy computer modeling and revisited data from their Voyager 2 spacecraft, launched way back in 1977, to figure out the makeup and structure of these moons. They found that Titania is huge enough to keep its internal heat and prevent its ocean from freezing. But get this, the other moons might have a chance at having warm oceans too. The researchers discovered potential sources of heat in the moon's rocky mantles that could release hot liquid and keep the oceans warm. And guess what? The oceans might even be warm enough to theoretically support life. The study also found that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as antifreeze, and salts in the water could also help maintain the ocean's temperature. Now, you might be thinking, how can these icy moons have liquid water? Well, turns out their internal heat and some chemicals could make it happen. For example, a study revealed that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as antifreeze, and salts in the water could also help maintain the ocean's temperature. And if these moons really do have oceans, that means there could be other ocean worlds in our solar system and beyond. But don't get too excited, these oceans are pretty salty, about 150 grams of salt for every liter of water. That may not be saltier than Utah's Great Salt Lake, but still. As for Uranus's 5th biggest moon, Miranda, well, it might have had an ocean at some point, but it probably froze over pretty quickly. Poor little guy. Anyway, NASA is thinking about sending a mission to Uranus to learn more about these icy giants and their moons. They're calling it the Uranus Orbiter and Probe. UOP. Sounds like a party to me. So yeah, technically there might be not 4 but even 5 oceans, but there's still much to learn and explore. Fasten your seatbelts. We're setting course for the most bizarre places in our universe, and you'll see the most mysterious phenomena few people have ever seen before. Recently, astronomers have discovered that the supermassive black hole at the center of our home, Milky Way galaxy, might be leaking. Why is it a significant change? Because it might mean that this black hole, called Sagittarius A, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active. And the leakage recorded by scientists may be the whole hiccuping while swallowing clouds of gas. Hey, I've been known to do that from time to time. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often occurs around other active black holes surrounded by the material drawn to them by their immense gravitational pull. Some of this material gets pulled into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches small jets of matter. Fermi bubbles might be the result of the belches that occurred around 2 to 4 million years ago. But recently, scientists have found another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now, let's visit some other breathtaking places in our universe. But be very careful. Some of them are extremely dangerous. Like this rotating neutron star called the Black Widow Pulsar. Just like its spider namesake, it's munching on its partner. a lightweight brown dwarf star. The more material this pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. If it does exist, nuclear pasta is the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. How about visiting a planet where it rains glass? I'd rather not. This bright blue exoplanet looks peaceful and slightly familiar. Don't you think it slightly resembles Earth? But this pretty appearance hides the planet's terrifying nature. The winds blow at 5,400 miles per hour on its surface. It's 7 times the speed of sound. But that's not the worst. It rains glass, sideways, in this scorching hot alien world. Solar tsunamis are a solar phenomenon dubbed Terminator events. These tsunamis take place at the sun's equator. Disastrous magnetic field collisions seem to cause ginormous twin tsunamis of plasma. These tsunamis tear across the star's surface, moving at a speed of 1,000 feet per second. They can last for weeks at a time and happen every decade or so. Look at this space body. Its nickname is Electric Hyperion. This Saturn's moon is one of the most bizarre-looking moons in the solar system, but its appearance isn't the strangest thing about it. This pumice stone-like rock, pockmarked with countless craters, is also charged with static electricity, and it's flowing out into outer space. Look at this, a rogue planet with auroras. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars, but one of them, 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates flashing auroras in the planet's atmosphere. Stay away from black holes. Do I really need to warn you? Yep, they're some of the most perilous objects in the universe. But how about mini black holes? Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 sedans. One theory claims that tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. Ah, I bet you'll like our next stop, a burning ice planet. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means it's traveling remarkably close to its parent star. That might be the reason the planet's temperatures rarely drop below 800 IF. But the strangest thing, the planet hosts huge volumes of water ice known as Ice X, which remains solid despite blistering temperatures. If you love jewelry, this next world is for you. A diamond planet. About 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline. This, in turn, might mean that at least some part of the planet is diamond. Moons orbiting other moons might exist, or they might not. Astronomers haven't agreed on this one yet. Planets orbit stars and moons orbit planets. But then, why can't there be moons? Also known as submoons, moonettes and moons. It actually sounds like one of those flowery Hawaiian dresses, you know, moo-moos. But alas, no. Researchers claim that moons could exist, but the host moon has to be massive enough, the moon, small enough, and there must be a wide gulf between these moons and the host planet. Now, I'll take you to the living fossil galaxy. DGSat I is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy unique is that it's sitting all alone. Unlike other galaxies of this kind, those are usually found in clusters. It can mean that DGSat I was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, this galaxy is a real living fossil. Now, you won't be able to see the next space phenomenon, all because people can't see infrared light. And the phenomenon I'm talking about is an infrared stream from space. Neutron stars are ultra-dense collapsed cores of giant stars. They usually emit X-rays or radio waves, but in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. This signal was probably generated by a disk of dust surrounding the star, but this theory hasn't been proven yet. Behind the orbit of Neptune lies the mysterious Kuiper Belt, filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding from our sight a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed. Or not. Let's visit our star, but we need to be careful not to come too close. Because the sun's atmosphere is hotter than the surface of the star. While on the surface the temperatures reach 10,000 RF, the upper atmosphere heats up to millions of degrees. Scientists suspect that explosive bursts of heat from the sun might have something to do with this unique phenomenon. This space object is also worth visiting. Haumea, a dwarf planet orbiting in the Kuiper Belt, has a bizarre, elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning big object in our solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile wide ring circling it. Ring-a-ding-ding! Jupiter is the largest planet in the solar system. More than 1,300 Earths could fit inside this gas giant. It's also 2.5 times more massive than all the other planets of the solar system combined. But if you think this is mind-boggling, I've got some great news for you. Very recently, a team of astronomers has discovered a much, much bigger planet with the help of the Subaru telescope and the NASA Hubble Space Telescope. It's a Jupiter-like protoplanet orbiting a very young star called AB Aurigae. The star is probably still forming and is no more than 5 million years old. For comparison, our Sun is 4.6 billion years old. The young star is located around 531 light-years away from Earth, in the constellation of Auriga. The star is shrouded in a thick, quickly moving layer of gas and dust. This disk feeds the growth of the star. Later, what is left of this disk will come together to form the elements of the planetary system. Planets, dwarf planets, comets, asteroids, you name it. But back to the newly discovered planet. It's a gas giant whose mass equals that of 9 Jupiters. Can you imagine this colossus? It takes the planet, named AB Aurigae b, almost 588 Earth years to complete just one journey around its parent star. Maybe because it's 93.9 AU, astronomical units, away from it. Now, why is the discovery of this planet so amazing? Because according to astronomers, it's been forming in a very bizarre way. Or should I say, eyes forming, since this gas giant is still in the process. Anyway, the unusual thing is that AB Aurigae b is coming together as a result of a top-down gravitational collapse of giant clouds of gas. But scientists say that a much more common model of planetary formation is when dust and rocks gradually accumulate around some kind of core. This proves the idea that there are numerous ways for planets to form. It can also mean that there probably are very diverse planetary systems in our home Milky Way galaxy. But AB Aurigae b isn't the largest exoplanet ever discovered. In 2005, astronomers spotted a mysterious space body. Later, they called it GQ Loopy b. The thing was orbiting a young star at a distance 2.5 times greater than that between the Sun and Pluto. Scientists came to the conclusion that the object was either a planet or a brown dwarf, which is basically a tiny star. If astronomers decide that GQ Loopy b is a planet, it will be the largest ever found, with a radius that is 3.5 times that of Jupiter. The biggest star we know about is called Scuti. This hypergiant has a radius that is about 1,700 times greater than that of the Sun. If you somehow managed to place Scuti in the center of the solar system, its edges would stretch far beyond Jupiter's orbit. As for the dust and gas streaming from the star, all this would extend beyond the orbit of Pluto. That's 400 times the Sun-Earth distance. A black hole is a spot in space where the pull of gravity is so strong that even light can't escape it. But why is gravity so powerful there? Because matter is squeezed into a teeny tiny space. Supermassive black holes, which can be many millions of times the mass of the Sun, tend to lurk in the centers of galaxies. The most massive black hole astronomers have discovered so far is TON 618. Its mass is equal to that of 66 billion suns. It was the year 2010 when, with the help of the Fermi telescope, astronomers spotted ginormous something entering the Milky Way. Their discovery looked like massive blobs of matter that could only be observed in particular wavelengths of light. They were also about 25,000 light-years tall. Scientists think that the blobs, called Fermi bubbles, could be produced by our galaxy's central black hole. Space seems to be extremely deserted, but some places are even emptier than the rest, like Supervoid in Eridanus. Astronomers noticed this huge region of empty space in 2004. The area stretches 1.8 billion light-years across. It's mysteriously devoid of gas, dust, stars, and even dark matter. A nebula is a massive cloud of gas and dust floating in space. Some nebulae form when a star is nearing the end of its life and throws out loads of gas and dust. Others appear in regions where new stars are forming. The largest nebula we know about is the Tarantula Nebula. In its longest span, it measures over 1,800 light-years. This nebula, also known as 30 Doradus, is located around 170,000 light-years away from Earth. Unlike its namesake, the tarantula isn't dangerous. Quite the opposite. It's a stellar nursery, which means it's a region where tons of young stars are born. Even cooler, it's the most active star-forming area in our entire galactic neighborhood. In 2021, the biggest ever comet we know about entered our solar system. It was 85 miles across, and its icy nucleus was 50 times greater than the nucleus of the previous record breaker. The intruder's mass was a whopping 100,000 times bigger than that of an average comet. In fact, C 2014 UN 271 Bernardinelli Bernstein was so large that astronomers first classified it as a minor planet. Is it going to crash into Earth? Nah, it won't get closer than 1 billion miles to our beautiful green planet. And it won't happen until 2031. But could there be comets even bigger than that? Who knows? But the thought is terrifying. There are loads of bizarre things in the universe, and hypothetical nuclear pasta is one of them. If it does exist, nuclear pasta is the strongest material in the entire universe. It forms from the leftovers of extinguished stars when this substance gets squeezed into spaghetti-like tangles of material. It can theoretically break, but only if you apply 10 billion times the pressure needed to shatter steel. Pulsars are spherical space objects the size of a large city, but they pack more mass than the entire sun. They radiate 2 narrow beams of lights, sending them in opposite directions. The Black Widow pulsar, just like its spider namesake, is munching on its partner. It's a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes its companion star to dwindle. Haumea is a dwarf planet orbiting in the Kuiper Belt, a donut-shaped ring of objects around the Sun that extends just beyond the orbit of Neptune. The mini-planet has a bizarre elongated shape and 2 moons. The day on this planet lasts just 4 hours, which makes it the fastest spinning large object in the solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile wide ring circling it. What is it? Where did it come from? No one knows. Could be the result of a collision that happened in the distant past. The 18th brightest star in the night sky, Fomalhaut, is a terrifying sight. It's dubbed the Eye of Sauron because of a ring of dust and debris circling it. It makes the star look like a giant eye staring into your soul. The intimidating star is more than twice the mass of the Sun. It's 25 light-years away from Earth, which isn't that far away, considering distances in space. Look at this butterfly. Its wingspan is more than 3 light-years. And the structure inside this nebula is one of the most complicated ever observed. The nebula's central star, a white dwarf, is heated to an incredible 450,000 EJ/F. It means it was formed from another gargantuan star more than 5 times the size of the Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass, or a butterfly. There's this mysterious thing in space, an unusual spot that scientists haven't been able to explain for more than 15 years. There are different theories, and one of them says that maybe this is an imprint from a collision with a parallel universe. Is this true? Well, let's see. Take a look at this map. This is the map of our universe. Well, not really. This is actually the map of cosmic microwave background radiation, or simply CMB. Many, many billions of years ago, there was a Big Bang. It was so powerful that it created our entire universe. And of course, such an event couldn't occur without leaving some consequences. And these consequences are literally everywhere. The Big Bang left electromagnetic radiation, which we know as CMB. We don't notice it in our daily lives, but it's literally here, under our noses. And if you had some kind of superhuman vision, you would see how everything around you shines with this dim light. This radiation is very important. If we hadn't discovered the CMB, we would have never found out about the Big Bang. Previously, scientists believed that the universe had always existed. There was no beginning, and there won't be an end. It sounds pretty ridiculous to us now, but less than a century ago, people were absolutely sure of it. Stephen Hawking was one of the first scientists to guess that the universe did, in fact, have a beginning. The guy was so cool that he realized this as a student while working on his doctoral dissertation. But, unfortunately, he had no proof. If there was such a strong bang billions of years ago, then where are the traces? Where's the proof? Laughed people who believed in the eternal static universe theory. But don't worry, they had the proof rubbed in their faces real soon. In 1965, astronomers Arno Penzias and Robert Wilson discovered CMB, and that was the first grandiose proof of the Big Bang. It turned out that radiation was everywhere. We just didn't notice it. In fact, at first, Penzias and Wilson themselves mistook it for the noise of a big city, or pigeons, or something else. For their discovery, which turned the world of science upside down, they received the Nobel Prize. Alright, so people learned that they were surrounded by electromagnetic radiation. Then, they started collecting more data about it. They accumulated more and more info over the years until they made this very map. This is a map of CMB temperatures. But while creating it, scientists discovered something unusual. Let's take a look at this map. It looks like a large and diverse pattern of cold and warm places. But in reality, our universe is quite uniform. All temperatures on this map are close to 455 degrees with very little difference. All temperature fluctuations between these places are small, and each tiny speck actually spreads over millions of light years. So everything in our world is pretty calm and stable, except for one point: this cold spot right here. Astronomers first discovered it in 2004. First, it looked like nothing unusual. It's just a region where the temperature is below average for a couple of microkelvins. But remember, we're not talking about a small area. This is a giant cold region. It's literally billions of light years in size. Wait, the scientists thought, this can't be true. The universe should be consistent everywhere. According to our standard model, this cold spot simply shouldn't exist. But it does exist though. This isn't just some mathematical error, it's right there. So, what is this cold spot and how did it appear? Astronomers have been trying to find the answers to these questions for years. Even now, we have only a few theories. So let's discuss them all. Theory 1, cosmic texture. This idea was brought up at the end of 2007. Then, scientists suggested that this cold spot could be the hills of space. In other words, it may be a bumpy region of the universe, just part of its texture. But that's a silly explanation, so this theory was quickly discarded. Theory 2, the supervoid. This hypothesis was considered the most plausible for a while. It stated that the cold spot was actually the so-called supervoid. It's a terrifying, dark place of our universe with almost no galaxies. And because it's an empty region with almost no stuff in there, it seems cold to us. However, this theory was refuted in May 2017. After carefully examining the cold spot, scientists found out that there were no signs of a supervoid there. Moreover, voids and supervoids, which actually exist by the way, are still very small in size. The cold spot is literally thousands of times bigger than them, so there must be some other explanation. And there is one, perhaps the most bizarre of them all. Theory 3, a parallel universe. This controversial idea was put forward by cosmologist and theoretical physicist Laura Mersini-Houghton. She suggested that the cold spot could be an imprint from the collision of our universe with a parallel one. Standard cosmology cannot explain such a giant cosmic hole, says Mersini-Houghton. This is the unmistakable imprint of another universe beyond the edge of our own. Her assumption is based on the theory of the multiverse. This theory says that there's actually an infinite number of universes like ours in the world. They constantly collide with each other, giving each other a push, which creates a new Big Bang. So maybe the cold spot is a bruise from such a collision? For quantum mechanics, such crazy theories are pretty common. But for standard physics and our simple understanding of the world, this is earth-shattering. Of course, we need strong evidence. And Mersini-Houghton's team has begun to work on it. Professor Tom Shanks from the Center for Extragalactic Astronomy at Durham University also participates in this research. The craziest sounding of the exotic models for the explanation of the cold spot, the multiverse is actually the most standard in terms of our current model of the universe, he wrote in one of his works. So, what evidence do we need? Well, our cold spot is located in the southern hemisphere. According to Shanks, if there really was a collision between two universes, we should find another cold spot, and it should be in the opposite northern hemisphere. If astronomers actually found it, this theory would be confirmed, and it'd become the first proof of the existence of a parallel universe. But it's not that easy. To find a second spot, we need the latest, highly sensitive telescopes. We also need to find out some info about the nature of dark energy, how it affects space, and, in other words, there's still a lot of work to do. Not so long ago, scientists actually believed they had discovered the second spot. Researchers from New Mexico thought they had found it in the northern hemisphere. But unfortunately, this is likely to be a mistake. The map these researchers used had a high measure of randomness, so it's possible that their discovery is just an accident caused by other voids. So basically, we haven't found another cold spot so far despite careful analyses. But again, even the best modern equipment is not perfect, and it doesn't mean that there's no second spot. It just means that we haven't found it yet. But if one day we did find it, it could change the world of science forever. We'd confirm not only the theory of parallel universes, but also the famous string theory, and it could explain everything that occurs in our world. But if this happens, we'll get even more questions than we already have. How did these two universes collide? How does it all work? So far, it's all just guesswork. We can't claim that the cold spot is a print from the collision of parallel universes, but we can't refute this either. Actually, we may never know the truth at all, but it's still interesting to strive for it. Imagine a black hole, a terrifyingly dense space object, pulling inside everything that comes too close. Nothing can escape its clutches, even a beam of light. And now, imagine two of these space monsters colliding. Scary? You bet! Astronomers have spotted two supermassive black holes feasting on the cosmic material of two merging galaxies in distant space. This phenomenon is the closest to colliding black holes we have ever seen. Supermassive black holes are the largest among all black holes out there. Their mass can be hundreds of thousands or even millions to billions of times larger than of our suns. And two such giants have been recently spotted with the help of an array of telescopes in northern Chile's Atacama Desert. Astronomers originally used these telescopes to watch two merging galaxies located approximately 500 million light-years away from Earth. Thanks to being alert at all times, scientists have also noticed that two gigantic black holes were growing alongside each other. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, only 125 million times larger. We can't see black holes directly. If you were to travel to a black hole, you wouldn't notice it until it was too late. The only detail that would give away the approaching black hole would be a slight blurring of distant stars due to the hole's gravitational lensing effect. The two black holes we are talking about are no different. They aren't visible directly, but are surrounded by bright clusters of warm, glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Time will pass, and these black holes will start circling each other, and eventually they will collide, creating one, probably even bigger, black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which, astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. The thing is, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around the black holes. Imagine how surprised astronomers were when, instead of one black hole, they discovered two of them, munching on the dust and gas stirred up by the massive space merger. Galaxy mergers are way more common in the distant universe than in our neighborhood, and this discovery may mean that such black hole binaries are likely to be much more common than we previously thought too. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves. These waves, also known as ripples in space-time, occur when black holes collide. If we talk about the recently discovered pair of black holes, it might still take them several 100 million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes there are that are about to collide in the universe. Also, this may give us more insight into what is going to happen when our home Milky Way galaxy collides with the Andromeda galaxy in around 4.5 billion years. By the way, the first photo of a black hole was taken in 2019. An international team of scientists consisting of more than 200 astronomers had been working for years to get this result, and their efforts finally paid off. The object in the photo is about 55 light-years away from Earth, at the center of the galaxy M87. You can now admire this amazing space phenomenon thanks to the work of a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. The event horizon is a point of no return on the outskirts of a black hole. Once something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape. To capture the very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order, with the help of precise atomic clocks set on each telescope. Plus, they were constantly monitoring the amount of moisture in the air, since too much humidity would ruin the images. To keep the chances of rain to a minimum, they even constructed the telescopes in super dry regions such as the Atacama Desert in Chile and the South Pole. All in all, the process resembled a carefully coordinated dance. But thanks to these preparations, in over 2 weeks, the telescopes collected 5,000 trillion bytes of data. It was then processed by several supercomputers, and scientists finally got the long-awaited images. And what they observed was a monster of a black hole measuring about 25 billion miles across. Now how about we talk about the coolest black hole facts? There are baby black holes called primordial, and they are really tiny. They vary from the size of an atom to that of a mountain. There is a theory that galaxies get formed around black holes. This means that when a large star explodes, a black hole appears in its place, and then the rest of the galaxy just forms around it. There is a supermassive black hole right in the middle of the Milky Way galaxy. Its name is Sagittarius A star, and it's 4 million times as heavy as the Sun. And nope, we aren't going to be pulled into this hole. It's more than 26,000 light-years away from Earth. That's too far for this monster to have any influence on our planet. Besides Sagittarius ASA, there are 100 million medium-sized black holes in our galaxy. And can you imagine how many black holes in total there are in all 100 billion galaxies that exist out there? You do the math. If you ever find yourself near a black hole, be ready that time will slow down significantly. It may work for you if you aren't so eager to grow older. Just don't let yourself be tugged into the event horizon. Whoops! Bye-bye! Black holes aren't some hungry predators that roam the universe preying on poor, unsuspecting planets. They just gulp down the stuff that ends up too close to them. On top of that, they sometimes fling out spitballs the size of a planet. How does this matter escape the pull of black holes? Typically, it manages to slip away before going past the point of no return. In fact, with Sagittarius A, we should be worried not about its gravitational pull, but about the very spitballs. After all, the monster black hole hurls them in the direction of Earth at a speed of 20 million miles per hour. What if one day one of them reaches our planet? If you managed to squeeze Earth to the size of a cherry tomato, it would turn into a black hole. In fact, you could also become one if you agreed to be scaled down to an atom. South African astronomers have recently come across another head-scratching black hole mystery. In a region of distant space, they noticed that several black holes located in different galaxies aligned in the same direction. It looks as if their gas emissions have been synchronized by design. Nowadays, scientists can't explain why and how black holes, which are about 300 million light-years away from one another, can be acting in unison. It's a puzzlement. The center of the Milky Way is a story of intense radiation. gravity, and mystery. A place where the forces of nature are pushed to their limits. But what if our own planet were to find itself in this cosmic theater? What would happen if the Earth were located there and somehow managed to survive? Let's start this journey to the heart of our galaxy and find out. Picture this. You're floating in space, surrounded by billions and billions of stars. Suddenly, you see a bright, swirling mass of gas and dust in the distance. That, my friend, is the Milky Way galaxy, our home in the vast expanse of the universe. The Milky Way is estimated to contain over 100 billion stars and is about 100,000 light-years across. In other words, if you were traveling at the speed of light, it would take you 100,000 years to cross the Milky Way from one end to the other. It's a couple trillions of miles. And it isn't just a static collection of stars and gas. It's a dynamic, evolving system. In fact, the Milky Way is currently hurtling through space at a speed of about 1.3 million miles per hour. One of the most fascinating things about our galaxy is its shape. The Milky Way is a spiral galaxy, which means that it kinda looks like a disk with a central bulge and spiral arms. The spiral arms are the areas where new stars are born. It's where the most stars, gas, and dust are concentrated. And this is where the solar system is located. Our system is like a tiny speck in the grand cosmic tapestry of the Milky Way. It's about 26,000 light-years away from the center of the galaxy, a pretty long distance, isn't it? The solar system is also moving through the Milky Way as it orbits around the galactic center. It takes about 230 million years for our system to make one complete orbit around the galaxy. Just imagine that. Since the time of the dinosaurs, we've traveled just a quarter of this way. The position of the solar system in the galaxy affects our life in many ways. For example, things like the amount of radiation and cosmic rays we're exposed to, and even the likelihood of asteroid impacts and so on. Also, thanks to our location, we can enjoy some pretty amazing views of the universe around us. From our vantage point in the Milky Way, we're able to see other galaxies, nebulae, and star clusters in breathtaking detail. We're also a part of a pretty happening neighborhood, with lots of other stars and planets nearby, so we're lucky fellows. But what would happen if we weren't so lucky? What if the Earth was located in the center of the Milky Way instead? The center of the Milky Way is home to a region of space called the central bulge. And it's just packed with stars. It's like a disco ball, but instead of shiny mirrors, it's covered in stars. Only this disco ball is really huge, about 10,000 light-years in diameter. The center of the Milky Way is also home to some extreme environments that would make even the bravest astronaut shiver. High-energy particles and intense magnetic fields can wreak havoc on electronics and spacecraft. Intense radiation fields can fry anything in their path, so it's not exactly a friendly place for life as we know it. So, if the Earth were located somewhere closer to the center of the Milky Way galaxy, it would be a very different place. Let's take a look at some of the potential effects. First of all, radiation. As we mentioned earlier, the center of the Milky Way is one of the most radiation-dense regions in the galaxy. It would make life on Earth very challenging, if not impossible. Sure, we have the Earth's magnetic field. It's like a giant shield that protects us from harmful radiation from outer space. But could it protect us if we were located in the center of the Milky Way? Unfortunately, the answer is no. It's kind of like trying to use a tiny umbrella to protect yourself from a massive storm. So it would be an easy win for the galaxy. But it's not all doom and gloom. There are some brave organisms that are able to adapt to high levels of radiation. We've seen that life on Earth has evolved to survive anywhere, from the depths of the ocean to the icy poles of the planet. So let's imagine what would happen if we somehow evolved to survive in these harsh conditions. Like, picture humans with tough, scaly skin that protects them from radiation and plants with unique structures that allow them to thrive in this bright environment. In that case, radiation still could have some seriously spooky effects on us. For example, it could damage DNA molecules and cause mutations. Imagine a world where plants grow with 5 leaves instead of 4, animals have strangely colored fur, or people have unusual eye colors or other unique features. And these are just some of the best examples. Let's not dive into the bad ones. Also, it could cause us to undergo some metabolic changes. Maybe our bodies could process food and other resources more quickly, which could lead to faster growth rates and larger sizes. Plants could grow tall and thick, and animals would be much larger than usual. There are also some organisms on Earth that are able to bioluminesce. Thanks to high levels of radiation, these organisms could potentially glow even brighter than usual. Imagine walking through a forest at night and seeing trees, mushrooms, and even insects glowing with an eerie blue or green light. Frightening and amazing, isn't it? But let's move on to the next big change: gravity. The gravity in the center of the Milky Way is incredibly strong, all thanks to a supermassive black hole, which is about 4 million times the mass of the Sun. This black hole is called Sagittarius A, and yep, it's our neighbor now. Great. And assuming we don't get swallowed by this black hole or crushed by this incredibly strong gravity, it still could trigger lots of earthquakes and volcanic eruptions. This black hole would be like the gravitational bully, pulling and tugging at everything in its path. Basically, if we survived this, we'd have an epic surfing competition every single day. Just add a bit of thrill of risking your life, and forget about running away from the planet. No easy rocket launches anymore. And physical objects won't be the only ones affected by gravity. Time would flow very differently for us. According to Einstein's theory of relativity, time passes more slowly in areas of high gravity. In other words, Earthlings would age more slowly than someone far away from the center of our galaxy. Also, the center of the Milky Way is a very busy place. Stars, planets, and other celestial objects moving around at incredibly high speeds there every day. The positions of stars and other objects would constantly be changing. In other words, say goodbye to normal navigation. The GPS systems would likely be unreliable due to the strong gravitational forces and high radiation. So if you accidentally got lost in a glow-in-the-dark forest with some creepy animals, good luck. But it's not all bad. The center is also home to molecular clouds. These are the regions of space where new stars are born. And the Milky Way in general has some pretty amazing sights to offer. For example, stunning nebulae like the Orion Nebula and the Eagle Nebula, which are visible with telescopes or even just a good pair of binoculars. So, if Earth were located in the center of the Milky Way, we would have a front row seat to some of the most spectacular cosmic events. Wouldn't that be awesome? Overall, if Earth were located in the center of the Milky Way, it would be a very different place. Of course, we all understand that our planet wouldn't have survived such a change, but it's still pretty interesting to imagine how our life would flow if we were there. And judging by what we just discussed, it wouldn't be pretty. So let's treasure and appreciate our small, quiet solar system.